Hello, welcome to this video on 9-4, and we are talking inverse trig functions. This lesson, I'm going to split it into two parts. The first video is just going to be a review or a recap of inverse trigonometric functions from either pre-calculus or accelerated math 3, and then the second video will focus on the calculus of inverse trigs. Okay, so let's go ahead and let's refresh our brains, kind of dust off those cobwebs about inverse trig functions. So, the first part of it, right, is that inverse trig functions are inverses of trig functions. That's why they're called inverse trig functions, right? And with inverse functions, the domain becomes the range becomes the domain. So you'll kind of see that here with sine and cosine, right? The new domain for these functions is -1 to 1. And that makes sense if we think about the outputs on a unit circle, right? The south pole, that value is -1. North pole, that value is 1. So those are our new domain values, okay? And they're inclusive. Now, the range values, you'll notice here that they're adjusted. It's not all real values. I can't go from 0 to 2 pi, 4 pi, 8 pi, or even in the negative direction, right? The reason for this is that none of the basic 6 trig functions are 1 to 1. So what we have to do is we have to kind of restrict where we're looking, right? And if you consider the sine function, so here I'll go ahead and do my best to draw a sine function, and what we want is we want to capture from -1 to 1. And so what we do with the sine function is we limit the domain from -pi/2 to pi/2, okay, inclusive. So that is our new range. With cosine, it is from 0 to pi, and then with tangent or arctan, it is from -pi/2 to pi/2. Okay, so we can capture all those values. Now, again, keep in mind with tangent, right, the graph of that, it goes up, okay, forever and down forever. So the new domain is -infinity to positive infinity. You can plug anything in, but again, the range is limited between -pi/2 to pi/2, non-inclusive. We don't include those pi/2s. Remember, we have undefined values there. Okay, so they want us to go ahead and graph the indicated inverse trig functions in the coordinate plane below, okay, and arc sine. So if I go ahead and graph the inverse, it looks something like this. Inverse of cosine, arc cosine, looks something like this. Okay, and the inverse of arctan looks something like this. Okay, and again, now this is because we have an asymptote here, right? At -pi/2 and at pi/2. All right, and we have arrows on this one. The domain is -infinity to infinity. Okay, now how the heck do we get these values? Well, again, you switch your x and your y value for a sine function or a cosine function, and these are the graphs of the functions, okay? So something just to keep in mind. Something that's really important is our next section here, and this is called the geometric representation of the range values. Really, it's just kind of a visual aid to help you remember the range values, okay? And I just want to go over them briefly, and I want to highlight arc sine. Arc sine goes from -pi/2 to pi/2 inclusive. So when we're calculating values, all of our angles will be from 0 to pi/2, and then also in the negative direction if we're dealing with negative values. For arc cosine, okay, the negative values are found in quadrants 1 and quadrants 2. So here are your cosine values, right? 0 to pi. Okay, and then tangent is the same as sine, going from -pi/2 to positive pi/2. However, again, notice this open circle here means we are non-inclusive to those values, right? Our function is undefined there. Okay? All right, so what are some of the mistakes that you can try to avoid? Well, the first one is make sure that you know your range values. Do not put an inappropriate range value for an answer or put more than one. So for instance, if I'm calculating what is arc sine of negative 1/2, okay? Well, this occurs at the negative pi 6 angle. That's the only correct answer, right? It's the only answer. Now, I know maybe you're used to thinking, okay, well, that could occur at, say, 7 pi over 6, right, which is over here, and 11 pi over 6, which is again over here, but that's not in the range value of arc sine, right? We go from 0 to pi over 2, and then also 0 to negative pi over 2, negative pi over 2, to positive pi over 2. So your answer is negative pi over 6. It's the one and the only answer, okay? It's kind of easy, I think. I think it makes things much simpler. All right, example 2, here we go. It says, explain why arc sine of negative 1/2 is equal to 11 pi over 6, and arc sine of negative 1/2 is equal to 7 pi over 6 are not true. I was even tripping out reading that. I'm like, what? Explain why this is, what? This is not true. Why is it not true? Even though both of those values are negative 1/2 for sine. Well, again, the reason is because the range of arc sine, right? The range of arc sine, also known as sine inverse, right? Is negative pi halves to pi halves. Very simple. All right. Example 3, evaluate these answers without a calculator. Okay, so they want to know what is arctan of 1? Okay, so when does tangent produce a value of 1? And this, again, will occur at the pi 4th angles, right? Sine over cosine. So here, it would occur here, although it would be negative there. It would be positive in quadrant 3 and positive here. So what angle, right, will produce this, keeping in mind the range of arctan? And again, arctan goes from a negative pi over 2 to pi over 2, okay, non-inclusive. So this is going to be pi 4ths, right, at this angle here, okay? All right, arc cosine of negative 1. Okay, so now I'm thinking about cosine, and I'll draw a quick unit circle. So cosine's range goes like this, 0 to pi, and where is cosine, our x value, equal to negative 1? Well, that occurs right here at pi. Simple. All right, C. Where is arc sine negative root 3 over 2? Okay, again, arc sine, if I'm thinking about the range, it goes from negative pi over 2 to pi over 2. I'm clearly in quadrant 4, and I want my y value to be negative root 3 over 2. Okay, so this is going to occur at negative pi thirds. Not 5 pi over 3, right? It's just the negative version of pi thirds. All right, and then D, arc sine of 2. They're trying to get tricky here, right? They give you a domain of 2, and think about this. Like what's the sine value, or what angle, sine of what angle produces 2? And the answer is nothing. It only goes from negative 1 to 1. So inverse trig, right? For sine and cosine, the domain is negative 1 to 1. So they're trying to trick you here. Don't be fooled by their bag of tricks. This is non-existent, aka no solution, non-existent. All right. Example 4, we're going to go ahead and use a calculator. They want arc sine of 0.3. So cruise over to my calculator. Here it is. Hello, calculadora. And I want arc sine, I think that's the function I want, of 0.3. So I go to my trig button, bring up arc sine, I enter 0.3, and boom, there it is, 0.305, approximately 0.305. 3 decimal places, rounded or truncated. Make sure you know that. You should. I've said it like 5 million times. I'm going to say it one day, I'm going to have a heart attack like, my arm. Okay. Arctan of negative 5/2. Okay. I'm going to go trig. Arctan, aka tan inverse. And I want negative 5 halves. 5 by 2. Not 5 by 5. 5 by 2. Okay, and we get this value, negative 1.190. Approximately negative 1.190. If you plug that in, be careful. If you have like a CAS, if you plug this in, you might get that same answer like spit back out at you. You just have to hit Control Enter, right? You have to approximate it because the domain value of that function isn't a decimal, so they don't want to give you a decimal. I don't know. It's computers, right? Okay, let's go ahead and finish off. All right, so these functions are going to give you a trig function and an inverse trig function together, and they're going to have you compute some things. Now, the natural tendency is to go ahead and say, hey, sine and arc sine, these are inverses, they cancel, so our answer is root 3 over 2. Now, that works sometimes, and in this case, it does. How do I know if it works? Well, you have to ask yourself, okay, is this domain value here, root 3 over 2, is it in the range of sine? And the answer is yes. Okay, so that's the answer, right? Arctan of 3 is 3, okay, in the range of tangent? And the answer is yes. Okay, so these do cancel. Okay, how about pi thirds? Is pi thirds in the range of arc cosine, right? And maybe on these ones you have to draw yourself like a little sketch. Hey, here's cosine pi thirds is in there. So yes, these do cancel, and pi thirds is my answer. That's the super like quick, reckless way of doing these types of problems. The proper way to do this is to go over here and say, okay, what is arc sine of root 3 over 2? Okay, and you would say, well, that would be pi thirds. Okay, now what is sine of pi thirds? Root 3 over 2. Okay, and maybe you're like, nobody has time for this, Schwarberg. And I understand, right? But you're going to run into problems kind of like D, where D, 11 pi over 6. Is 11 pi over 6 in the range of arc sine, which is here? And the answer is no. So I can't just cancel these out. The answer is not 11 pi over 6. You'll get it wrong. You'll lose, and then that's not good. You'll cry, and we don't want that. Okay, so here's what you have to do. You have to say, okay, what is sine of 11 pi over 6? Sorry, I have to get myself oriented here. Okay, so sine of 11 pi over 6, okay, this is a pi 6 angle, and it's in quadrant 4, so that would be negative 1/2. Okay, and then what is arc sine of negative 1/2? Well, that's negative pi over 6. And there's your answer. Okay, so be careful. I kind of advise doing it this way. Okay, it takes maybe 2 seconds longer, but it's safer that way. Or just keep in mind, you know, the rules for that game. Okay, last example, example 6. They want us to solve for x, okay? I see x here, so how do I get x alone? Well, I have to undo the arc sine, okay? So how do you undo a arc sine? Well, do its inverse, which is sine. So I take sine of both sides, okay? These cancel, and I now have x squared minus 3 is equal to sine of pi halves. Well, sine of pi halves, hey, that's 1, okay? And I can go ahead, I can add 3 to both sides. I can take the square root of both sides, and we get x is equal to plus or minus 2. And that is it. Done. All right, hey, that's inverse trig. If you need more kind of mental refreshers on inverse trig, you'll want to go ahead and check out maybe some of my other videos if I have them up. If this is 2020, I do not have those videos up yet, but I'll have those videos up for my accelerated math 3 classes in the coming months. So sorry, my guinea pigs of calculus. I love you, but it is what it is. All right. You can just YouTube it, Google it, okay? And I know my Estes has some inverse trig videos. I'm out. Catch you in the next video. Peace.